Hello, everyone, scholar, colleagues, friends around the world. Welcome to Digital Tech Talk Series 2 of AIT Extension, Asian Institute of Technology, Bangkok, Thailand. Our two-day webinar on a blockchain premiere, insights and practical applications. This is Shaheen Hossain as MC and moderator of the event. To begin the event, let me welcome our Executive Director, Dr. Jonathan Shaw, for his opening message. Dr. Jonathan Shaw, please.
Thank you, Shaheen, and a very warm welcome to everybody attending this latest collaboration between Abalon Labs and particularly with Ivan Splebin and AIT. This is Jonathan Shaw, the Executive Director of AIT Extension, and we're delighted to have you with us here this afternoon. So the one thing that Ivan, I think I can claim without any doubt at all, he understands the practical applications of blockchain. This is really a webinar on what blockchain means in practice, and we're looking forward to, again, further insights from Ivan. We're looking forward to a lively conversation after the main presentation, and we're looking forward to learning more about the many often surprising applications of blockchain to various aspects of work that we're all engaged in. So thank you very much, Shaheen. A very warm thank you to you and to all of our colleagues in AIT Extension, and back to you. Thank you.
Thank you, Dr. Jonathan Shaw. Now, I would like to introduce our today's practitioners, speaker Ivan Spleeveen. I think who attend our that means first webinar on digital transformation, they already know him, but still now who are new and who are interested to know more about him, let me say something about Ivan Spleeveen. Ivan Spleeveen is a C-level executives and hands-on experts focused on helping companies and startups on their transformation. Ivan Spleeveen is a co-founder of Abalon Lab, to tech consulting and training firm as an organization focusing digital transformation, blockchain, technology, artificial intelligence, machine learning, and so on. So to know further on blockchain technology, I will not take too much time on that. Let's flow to our practitioners, Ivan Spleeveen. Ivan Spleeveen, please.
Thank you, Shaheen. Thank you, John, for the introduction. Always a pleasure to be back at AIT. And good afternoon, everyone on the webinar. Good to see so many faces that we've seen before in the previous session. And also welcome to all the new joiners today. We're having a session on blockchain this afternoon, an hour to sort of take a deep dive into what blockchain is, what it can mean for companies, what different types of blockchain there are. We'll also take a little look at cryptocurrency and how that works in the entire setting of blockchain.
Before presentation, I will just take a few minutes. Like, let me say something about how our participants will join or raise any questions during the event. Actually, our session will continue by Ivan Spleeveen 40 minutes till now, and at the end we have Q&A session. Participants can raise their hands to ask any questions, or can put their question and answer mode in chat box, or who are in live on Facebook, they can put their questions or any query on chat box. We'll reach to them as our possible. Thank you so much. So Ivan Spleeveen, please continue.
Thanks, Shaheen. And yes, very important to note that any questions are always welcome during the entire session. We'll try to cover as many as possible during the Q&A at the end. Don't hesitate to ask. Post them in Facebook Live, post them in the chat box if you're using Zoom, or raise your hand if you have a question during the session. Now I'm waiting for the presentation to start, and there we go. So today is about blockchain technology. Blockchain technology has been around for a while. A lot of people have heard about it, but don't really know what it is. Most people have it sort of an understanding of it in the context of cryptocurrency, and then mostly Bitcoin. And usually when I ask people, do you know what blockchain is? They're sort of like, yeah, I've heard about it. And when I ask, do you know what Bitcoin is? I say, yeah, that's a cryptocurrency. I've heard about that. very often more than they've heard about actual blockchain. So let's dive right into it and see, what blockchain actually is. And blockchain technology, in the simplest wording, is really a data storage framework. And more importantly, it's a tamper-proof data storage framework. So in other words, it is a database, like existing databases. Blockchain is a database, but different from a database is where you read and write and edit and delete information. In blockchain, you only read and write information. So blockchain is actually a database that is a growing list of records. It's an expanding list of records, and those records are linked to each other. So if you enter data in a blockchain database and you wish to change that data, you do that by entering another piece of data that is linked to the previous piece of data. So you have this continuous chain of data blocks that are all connected to each other, and that give you a historical view as well as an up-to-date view of what is going on with the records that you're keeping. So it is a database, it's a data storage framework, but it's a very different data storage framework from what people are used to with traditional databases. And the most important part about blockchain technology is that it is tamper-proof and resistant to modification of the data that it is contained within. The data that is uploaded to a blockchain is there forever. It can never be changed. It can be updated, but it can never be deleted. So you always have the option to go back and look at original historical data and trace your entire transaction through the entire blockchain back to the very beginning of the blockchain. So that data transparency is always present in blockchain technology, which is not actually present in traditional database technology. That's the biggest difference between the two, between databases and blockchain. So, most important thing to remember, we're talking about a tamper-proof data storage framework when we're talking about blockchain technology. Now, before I go into more detail, let's just take a quick look at the history of blockchain. And the history of blockchain, most people will have started hearing about blockchain around about 2008 or early 2009, when a white paper was published, and that white paper was talking about blockchain, and the white paper was talking about Bitcoin. And so you had a group of people or an individual, no one knows, by the name of Satoshi Nakamoto, that published a white paper to talk about blockchain and the application of blockchain, which was Bitcoin. Now, many people believe that that was the invention or the inventor or the people behind blockchain technology, which is actually not true. Blockchain was actually, as a principle, introduced by the NSA, which is part of the US government, in 1996. And they released a white paper back in 1996 on cryptography and how cryptography could be used to build a blockchain type solution. They had one issue with the solution that they were proposing, and it is that there is an ability to double spend transactions within that network. So they came up with a proposal to build a blockchain solution. They didn't call it blockchain, and they also knew that there was a limitation to the solution that they were proposing. That limitation was fixed by Satoshi Nakamoto back in 2008. So 12 years later, by introducing cryptographic hashes and by introducing the SHA-256 cryptographic algorithm to deal with double spending issues. And as it so happens, SHA-256, the algorithm behind the Bitcoin network, was also invented by the NSA from the US government. They just never put the two together. So Satoshi Nakamoto and the team, took those principles, added different principles together, and then came out with their blockchain solution, which was introduced to the public through Bitcoin technology. So important to understand is that Bitcoin and blockchain are related, but they're not reliant on one another. So blockchain is not reliant on Bitcoin to actually function, whereas Bitcoin is reliant on blockchain to actually function. But I'll talk about that, in a short while in some different slides. So blockchain, a tamper-proof data framework or database system. And what most people understand or don't understand about blockchain, because the implications for Bitcoin is that Bitcoin is a blockchain solution, which is a decentralized network. Now, blockchain can operate in a centralized network as well as a decentralized network. But it can operate much better in a decentralized network than a traditional database framework can. So if you think about a traditional database, it is stored on a server, it might be stored on a cloud server, it is somewhere where it is controlled by one or a group of individuals that are in control of the data that they're managing, the data that they're monitoring. Blockchain introduces the ability to make this decentralized. And if you look at the most famous blockchain application, Bitcoin, the Bitcoin network is distributed amongst all of the users of the network, which means that every single person that participates willingly in the Bitcoin decentralized network actually has a copy of the entire blockchain. They can't change that copy. It is tamper-proof, and I'll explain that in a little bit, but they all have a copy. That means if you want to change an instance of the data in the Bitcoin database, you would literally have to change more than 50% of, you would have to change that data on more than 50% of all the locations where that data is stored. So if you look at the Bitcoin network, you have 3 million participants. So there's 3 million copies of that same database distributed around the world. If you wanted to make a change, you would have to hack into more than 50% or more than 1.5 million computers and simultaneously change not just the data that you want to have changed within the database, but change all the subsequent data points that follow after that, because all of them are related to the hashing algorithm, which makes it incredibly tamper-proof. And if you look at Bitcoin as an example, it's been around for 12 years, and other cryptocurrencies have been around for 10 years or 8-9 years. None of them have actually ever been hacked as a data network. There's been problems with cryptocurrencies in terms of hacking of exchanges. There's been problems with third-party interventions, but there's never been a hack of an actual blockchain application, because it is virtually impossible to do. The magnitude, the computing power you would need, the magnitude and the breadth of distribution, because it is decentralized, will literally require you to hack into 1.5 million computers simultaneously, change the data simultaneously, distribute that data to the entire 3 million network, and get that data, that changed data, approved by that entire 3 million network, all within a split second, which is virtually impossible to do. It will be possible at some point in future with nanocomputers, but we're far away from nanocomputing power to date, at least on a wide scale. So you have a tamper-proof, decentralized data storage framework or database, which makes up blockchain. That is one of the biggest powers of that network, is the fact that the data cannot be changed. The other huge power of that network is that the data stored on a blockchain is extremely transparent. As I said in the beginning, the data that is stored there is kept there forever. If I enter on the blockchain and I say, look, I want to transfer $100 from my account to John's account, that transfer will be there and for all eternity. Now, we might, maybe I didn't want to transfer $100, I wanted to transfer $120. The only way to rectify that is to make another transfer of $20, or if I didn't want to transfer $100 but $80, to rectify that, John would have to transfer $20 back to me. That's the only way to change transactions on the blockchain, is to make another transaction. As I said in the beginning, the difference between blockchain and traditional database is blockchain is read and write only, where a traditional database is read, write, edit, and delete. So you can change the data that is there, and once you change it, it can be very, very hard to trace for anyone else to see that that data was changed. On blockchain, this is incredibly transparent because the data is always there. The historical data always remains there. The biggest benefit of this transparency is that, A, you can share that transparency with your decentralized network or with your centralized network, so everyone can see the original data versus the changes that have been made to that data. The other huge benefit is that it makes the data irrefutable. Once it is stored on the blockchain and it is accepted by the network that is managing that blockchain solution, that cannot be disputed. That data as it is there and is there visible for anyone with the right access. So you negate disputes about data accuracy immediately, because it is stored in a blockchain configuration. And the reason it's irrefutable is because of the consensus algorithms that it uses and the cryptographic hashing that it uses. Now, these might be foreign words to a lot of people, so let me clarify that a little bit. When the original blockchain concept was written by the NSA and when it was introduced to the world by Satoshi Nakamoto, it was always about cryptographic hashing. So what happens is they take the transaction. Again, the example of me transferring $100 to John, that is the entire transaction. Here's my account number. It goes from this account number to John's account number. Here's my name. Here's John's name. Here's the amount we're going to transfer, the date and the time. That is the transaction. What happens with that transaction, it undergoes a cryptographic hash. So there's a little piece of software that runs against it and that determines the hash value for this transaction. And that results in a 256-bit cryptographic string, which is unique to this transaction. And every cryptographic string is unique. There are an endless number of combinations you can use. They're alphanumerical. And so it's virtually impossible to have the same transactions string or cryptographic string occur twice in the world. So my transaction, me sending that $100 to John, is now identified by a unique cryptographic hash. So I can always find it on the blockchain using that hash. And if someone were to change that transaction, even by adding a space or a comma or deleting a space or a comma, any type of change would completely change the cryptographic hash that goes with it. So any change to my transaction would have an immediate transparent result in that the cryptographic hash is no longer the same. Now, these cryptographic hashes are important because they're connecting previous transactions to transactions that are taking place right now. And that goes all the way back to the beginning of the blockchain network. So if I do a transaction now, I incorporate the cryptographic hash of the previous block into my transaction, and therefore I get a unique hash for the block that I'm creating. And again, that cannot be changed, they cannot be tampered with. On top of that, when you're dealing with decentralized networks, you have a consensus algorithm. And that consensus algorithm can take shape in a variety of forms. It can be proof of work, which is known for the Bitcoin network. It can be proof of stake. It can be proof of a variety of things, proof of ownership. So you have an algorithm that regulates how consensus will be achieved within the blockchain framework. And again, these algorithms are run automatically. It's not human intervention that is taking place. They're the same with the cryptographic hashing. So you have computers doing the algorithm, the consensus algorithm calculations, and you have computers that are generating the cryptographic hash. Those two combined, the network having to approve a transaction through consensus, and the fact that the transaction has a unique identifier attached to it, and then is stored on the blockchain, makes it impossible to actually change that transaction without changing the entire blockchain, which would be transparent to everyone if that happens. Lots of technical jargon there, may not be clear to all people. The most important part that comes out of it is that because each transaction is unique and has a unique identifier, and each transaction is only entered into the database by consensus of all the participants, that makes the transaction transparent and irrefutable. And on top of that, more importantly, it removes the need for trust. If we go back to the same example I was giving earlier, if I'm transferring $100 to John, and in this case, I've obviously met John, we've known each other for quite a while, but even if I didn't know John, or John didn't know me, he doesn't have to trust me to do the transaction. He can trust the network. The network will give the consensus for the transaction to happen. The network makes sure that it is hashed and that it has a unique identifier. And therefore, it's the network that generates the trust, not the individual. So I can do a transaction with anyone anywhere around the world without ever meeting them and trust in the network to make sure that that transaction is true and accurate. So John doesn't need to know me. He can rely on the network to make sure that I have enough funds in my account to do the transaction, and he can rely on the network to make sure that the transaction actually takes place. And as soon as he receives notification of the network, he doesn't need to call me, he doesn't need to contact me, he doesn't need to contact any person. He knows that the transaction has gone through, and he knows that that transaction will arrive into his account. So there are no intermediaries in this process, or there's no need for intermediaries in this process. I don't need to trust a bank for the transfer to take place. John doesn't need to trust the bank for the transfer to take place. We can trust in the network, and the network is actually the one that's monitoring and ensuring that the transaction goes through. Now, this is a huge difference and change from how traditional databases operate, and how we place trust in institutions and individuals. Today, if you look at and again, the biggest example being cryptocurrency, if I have money and I want that money to be transferred around the world, without cryptocurrency, I have to go to a bank, which means I have to open a bank account. I have to trust the bank to manage my money. I have to trust the bank that they will not commit fraud on my account, that they will not charge me ridiculous interest rates and everything else, and sometimes they do, but I have to trust that they won't. I have to trust that when I put an international transaction or a national transaction into my account, that the bank will execute that transaction correctly. And as you may have experienced, banks quite often fail at doing what they're supposed to do well. Banks have all kinds of rules and regulations and all kinds of hurdles built in, where if you don't use your account often enough, they will freeze your account. And then you have to go through a strenuous process of reopening your account. If you're, when I was living in Hong Kong 10 years ago and I was transferring money from Hong Kong to Belgium, it would take 2 weeks to sometimes 20 days for the money to leave my account in Hong Kong and arrive into my account in Belgium. What happens in that 20 days is really anyone's guess. And when I say anyone's guess, I literally mean even the bank doesn't know exactly what route my money takes to go from Hong Kong to Thailand. So if the money doesn't arrive in Belgium, which has happened more than a few times, I would have to contact the bank in Belgium to find out if they've received it. I would have to contact the bank in Hong Kong to find out if they really send it, even though it went out of my account, more than 20 days earlier. And then the bank has to start tracing and checking and calling all the respondents bank and correspondence bank to find out where the transfer of these funds went wrong, because it doesn't go from point A to point B. It goes through a wide variety of intermediaries. So we have to trust the banking system to do that correctly. If you look at a blockchain network, a transaction is always between A and B. There is no wide range of intermediaries in between. Transactions are transparent, so I don't need to call a bank or the organizers or the people moderating network. I can simply look at the network itself and validate that the transaction has happened and that the transaction has arrived. And if it didn't happen, I will know immediately. It will not take me 20 days to find out. So there's huge differences between how data is managed and how trust is managed within a traditional network versus a blockchain network. As a result of this, you gradually are now starting to see replacement of traditional database systems by blockchain-based database systems. And we'll touch base on that later on in this hour, where I have examples of organizations and governments and banks even that are moving away from their traditional database operated systems, single point of failure systems, into decentralized structures because of the ability to make it transparent, because the ability to make it irrefutable, and to remove that need for trust because of the way the network is structured. Now, I've talked quite a bit about Bitcoin in this introduction and in the last few slides, so I want to touch base a little bit on the differences between blockchain and cryptocurrency. As I said before, you cannot run a cryptocurrency without a blockchain solution or blockchain technology in the background. Cryptocurrency only functions because it is based on blockchain technology. So you do not have cryptocurrency without blockchain technology. However, blockchain technology does not require cryptocurrency to function. You can run a blockchain solution without ever touching anything related to cryptocurrency. There doesn't even need to be a cryptocurrency in your blockchain solution. The two, in that sense, are not connected. They are obviously related because they came out at the same point in time, and cryptocurrency or Bitcoin was the primary example of an application of blockchain. However, you don't need to run a cryptocurrency to run the blockchain solution. There's a lot of blockchain solutions that have nothing to do with cryptocurrency whatsoever. You cannot, however, run a cryptocurrency without having a decentralized network. The whole underlying idea of cryptocurrency is to make it transparent, to make it decentralized, to not have it be controlled by governments or other institutions in most cases. And therefore, the underlying idea of cryptocurrency is it has to be decentralized. And the only way to really create a true decentralized network is to use blockchain technology where every node, every participant in that network actually has a copy of the entire database, and every participant is a safeguard of the entire database. And cryptocurrency, has to operate in a fully trustless environment because there is no central bank involved. There is no central government involved in most cases. So the participants in that network have to be able to trust the network because it's still about money, it's still currency. And therefore, they're running this on blockchain solutions. Biggest difference between cryptocurrencies and blockchain is that cryptocurrencies by nature are unmanaged. So for cryptocurrencies, there's no central authority. There's always the people that created the network. And there's various and different blockchain solutions out there. But then there's always the creators of that blockchain solution. So they start the cryptocurrency, but once they actually put the cryptocurrency in operation, it becomes a decentralized network, which means that every person on the planet, whether you have coins or money in that cryptocurrency, you can look at their database, you can look at their source code, you can look at the transactions in the network. It's completely transparent, it's completely open to the public, and anyone with an interest can actually go in there, investigate, and look at the cryptocurrency, how it is structured, how transactions flow, how many transactions there are, and you can go back all the way in time to the very beginning. So today you can go on the internet and go to like bitcoin.com or bitcoin.org, and you can look at the very first transaction that took place in that network 12 years ago, and you can look at all the transactions that are taking place in that network today, and everything in between. Cryptocurrencies, because they're blockchain-based, are 100% transparent, and again, they are unmanaged. Now, unmanaged means that they're managed by consensus algorithm, which means every participant in the network that is running this cryptocurrency has a vote in how the cryptocurrency is managed. That is a bit of a downside for cryptocurrencies. It's not a downside for blockchain technology. It's a downside for cryptocurrencies because of the decentralized nature, where if they want to make a change to the fundamentals, if they want to make a change to how the cryptocurrency operates, they need to get consensus from the entire network. So if I take the example of Bitcoin, 3 million accounts, 3 million users, that means that at least 51% of those accounts have to agree with the change that is being made to the network in order for that change to become effective. So you have to get 1,500,001 person to agree to a change in your network in order for you to make a software change to your network. So the decentralization, what helps with transparency, what helps with immutability of the network, does have a downside in getting consensus of that network. You need active participation and you need people to vote. Now, there are consensus algorithms that deal with that. I'm not going to go into that. We have other sessions on purely on consensus algorithms and how that works. But so it can be primarily automated, and robotics can come into play, but it is a bit of a downside of running a cryptocurrency. Blockchain itself, on the other hand, has various different applications, which I'll go into in the next slide, which doesn't require this network consensus. So it is actually easier to run a blockchain solution and a blockchain database without having the need of this cryptocurrency. So when we come into blockchain solutions and choosing the right blockchain solution, there is 4 different types of major solutions, and then there's 2 other subcategories for each of these types. The most well-known is a public blockchain, which is really what it says there. It's for the people, by the people, of the people. This is the examples of cryptocurrency. These are the Bitcoins and the Ethereums and the Nanos and the, whatever. There's 3,000 different cryptocurrencies out there, where a blockchain solution is created, which is completely decentralized, which operates completely on consensus for transactions, consensus for voting, consensus for changes. And this is completely run by the public, by the people that are using it, by the people that are transacting in it. They also have the decision power through consensus, through majority voting. So this is completely public, this is completely transparent. This is not owned by any individual. It sits on millions of computers. And it is open for anyone to participate in. The second example, private, is the absolute opposite. So you have private blockchains, and you have private blockchain solutions in place today that are completely private, where there is no decentralization or very little decentralization, but they're using blockchain because of the fact that A, your database is historically accurate, it is irrefutable, it is transparent, and transparent in this case to the people that get access to it. So the access here is limited, but the control, the change that will happen to the network is controlled by an individual or an institution. So these are purely private. These might be, blockchain-based databases run around, for example, medical data, where you don't want the public to necessarily have access to the data, but you want other people to be able to access it, and you want to remain or retain control of the management of the database. So there's a reason for having private blockchain solutions versus public blockchain solutions. And obviously, private blockchain solutions do not deal with cryptocurrency. There is zero need and zero use for cryptocurrency in those solutions. Then you have consortium blockchain solutions, which again, you may or may not have heard of Ripple, which is a banking solution, which is a blockchain-based solution that's implemented in European banks and Scandinavian banks, which is a consortium-based blockchain solution. So here we talk about a semi-decentralized solution or partially decentralized solution, which is managed by more than one organization. So here, when I talk about Ripple, it's managed by multiple banks. So each bank has the same amount of voting power, depending on, how much they control the network. And all the banks have to vote. In this case, all participants have to vote to make any changes to that network. So consortium being different from public in that it is still controlled, and it's controlled by a limited number of entities or organizations versus public being controlled by all participants, and private being controlled by one entity. Consortium is controlled by a limited number of entities, but there is still consensus that needs to be obtained before making any changes to the underlying structure, the software, or any upgrades to the software. And then you have a hybrid approach, which is the last type of blockchain solution, where hybrid is really generating your blockchain in a private environment, but then storing the data in a public environment. So it's sort of a mix between the first two, between public and private, where the generation, the creation of the data is managed in a private environment, but the access of the data is open to the public. And you can immediately think of examples where this might be relevant. If we look at today's day and age, COVID-19 is a perfect example where medical institutions or hospitals or research labs might be storing their research, the results of their research privately. They're doing this on their own computers, in their own data centers, in their own lab. But once they have results, they store these results, or they could store these results on a public blockchain, because the data that they're generating is important for everyone in the world to know, and important for everyone in the world to be able to validate. So if you look at a pandemic like COVID-19, blockchain could have made a huge difference in distribution of information and distribution of data, where labs could still have their research done privately, get to the results, and then publish their results on a blockchain, which is then accessible by anyone that needs access to it, whether there be other research laboratories, doctors worldwide, but also the general public that wants access to more information about what's going on in terms of research, or what's going on in terms of finding a solution, finding a vaccine, what type of tests are available. All that kind of research information, which is generated privately, could be stored on a public blockchain, which would then be accessible by anyone to see. So it's a hybrid between the two. And again, a clear example of where cryptocurrency has absolutely no role to play. So blockchain has a lot of different applications that don't tie into cryptocurrency. And as I said, each of these then has two subdivisions, which is centralized or decentralized. Even a public blockchain can still be centralized, so which is more of a hybrid approach, but you can be a public blockchain that's accessible by everyone. Everyone can do transactions, but the consensus is managed centralized, and centralized here would be a consortium setting where multiple entities have the power to approve or disapprove. And there's even a few cryptocurrencies that have this structure going on where they're working with proof of stake, which means that the people with the most stake in the network, the highest holders of a certain currency, have a higher vote because they are relying more on the network to be efficient, and therefore their vote has a higher say. So that becomes more centralized in terms of planning and decision making, which becomes a bit more exclusively controlled, even though it's a fully decentralized environment. And vice versa, you can have completely decentralized decision-making, even if you're running a private or a hybrid network. All depends on how you want to distribute the data, all depends on how you want the data to be accessible and the data to be visible by the public. So you can take, and when choosing a blockchain solution, very often when we're talking to customers, the customer will tell us, we want blockchain. And our response will be, okay, first, what are you trying to achieve? Are you trying to achieve more transparency? Are you trying to achieve, consensus? Are you trying to decentralize? Are you trying to centralize? What is it that you're trying to do? Your database structure, why do you want to change from a traditional database to a blockchain database? Our question always is first, why do you want to do it? And then let's look at, should it be private? Should it be public? Should it be, consortium? Should it be a hybrid approach between the two? And how do we deal with consensus? Do we do that centralized? Do we do that, decentralized? So those are all questions and answers we need to come to when we're talking to customers about, building blockchain solutions for them. All right, so let me give you a practical example of an application or potential application of blockchain, decentralized global data management. This example is Mediport. So Mediport is a platform that's on its way, that is being built, that deals with storage of medical data on the blockchain. So now, in order to access Mediport, you actually need another blockchain solution. It's called Bioport. And Bioport is storage of your digital identity on the blockchain. So, think about it. The identity that you have today, and your identity is given to you by the government. When you're born, the government, based on what a doctor says, issues a birth certificate. So it's the government that actually stipulates that you are you. The government issues your identity, your ID card. It issues your passport if you want to travel. It issues your marriage certificate, your divorce certificate. Anything you do in life, is always documented by the government. So Bioport takes that information, stores that on a blockchain together with your biometrical data. So your iris scan, your fingerprints, voice recognition, facial recognition, all your biometric data goes on there as well. This is all data your government already has, but it's on a decentralized network. So this means it's transparent, it's irrefutable, and that means that you are always you, and you are always you based on your biometric data. So you can always identify yourself based on simply being there as a person and scanning your eyes and scanning your face and scanning your fingertips. So you access the Mediport network using your Bioport digital identity. And that means that your medical data, think about it, you go to a hospital and the doctor does an examination and they get results of that examination. They'll give you the results, but they're not going to give you all the data of all the underlying tests. While in Mediport, all this data is stored on a blockchain, which means you, in principle, have access to it. It doesn't mean you can change it. Remember, in blockchain technology, it's a read and write only. So, you have to have the right to write into the blockchain. If you don't have that right, you can only read. So you would be able to see the medical data that is stored on your behalf by doctors, by hospitals, by dentists, by the various entities that you're using, and you would actually control access to that data. So you get to control who will actually be able to see your data. So what that means is that in this example, you log into your biometric identity, your Bioport, and from Bioport, you get access to your Mediport data. And there you then get to decide who gets access to your data. So here's an example where you could say, well, I'm going to the hospital because I have I'm not feeling well. I'm going to give the hospital obviously access to all the medical data so they can help figure out based on historical data what's wrong with me. Simultaneously, you're talking to the insurance company about taking on new medical insurance. You don't necessarily need to share with the insurance company that you broke your leg 15 years ago, because guess what? That is no longer relevant to your current health condition. An insurance company is interested in what's happened to you in the last 5 years, but anything before 5 years is really of no concern to them because it's no longer a prevailing illness. So within Mediport, you could say, well, I'm giving the hospital access to all my data, but I'm not giving the insurance company access to the same data. I'm giving them only the last 5 years and only what is relevant for the insurance that I'm going for. If your insurance doesn't include, for instance, dental care, then there is no reason for the insurance company to look at your dental records. Same with visual. The insurance doesn't cover visual care. There's no reason for the insurance company to look at, your eyesight and information about your eyesight. Similarly, today, as an individual, your medical data is stored in a hospital, at a dentist's office, at an optometrist's office, in various different locations. You have no idea where that data is stored. You have no idea what data is there. And, you know, like myself, I've lived in a wide variety of different countries in my life, about 7. My medical data is literally distributed all over the world. I have medical data in Belgium, in Hong Kong, in China, in Pakistan, in Thailand, in Malaysia, in Singapore, etc., where I've been to a doctor, to visit a doctor for whatever. And I have no access to that data, and I have zero control over what happens with that data. So in a solution like Mediport, you, because you're logging in with your biometric identity, you control the data and who gets access to the data. That also means that if you're traveling, you can give a caregiver in a different part of the world access to your data. You don't have to travel with a full medical record while on the road. You can see this data is decentralized, is distributed around the world, and anyone that is granted access can look at that data and use that data to help identify any illnesses. Similarly, a doctor, a caregiver could prescribe medication. They put that prescription on the same blockchain because, again, this is medical data, and you can open that blockchain to a pharmacist who simply looks on your blockchain, looks at your symptoms, looks at the prescription, sees which doctor issued it, and based on that can actually give you medication. So this is a purely practical application of blockchain where, again, you know, there's no monetary transaction involved, there's no cryptocurrency involved, but there's a huge amount of transparency of data. There's a clear control of the data. You as an individual, you know, control your own medical information in this example, and, you know, you control your own identity information in this example. So this is one practical application of blockchain. If you look at other industries, like banking industry, for example, we have one example here, which is live now, or going live now in Cambodia. It's postponed a little bit. It was supposed to go live earlier this year, where the Cambodian central bank has worked together with Soramitsu in Japan, and they formed a system called Bakong. And Bakong is a digital blockchain-based banking system that allows the unbanked in Cambodia to become banked, which means, you know, the population in Cambodia does not have a bank account today because banks, you know, these people don't earn enough money. They're not interesting customers for banks. The administrative overhead is too big. The transaction volumes are very large, but the transaction amounts are too small. And therefore, it doesn't serve a bank to service these customers. These are low income earners, very often farming communities that simply don't have bank accounts. And therefore, they're limited in the amount of transactions they can do, especially in today's evolving world, where everyone is using cards and they're using phones for payments. And these people don't have a bank account and therefore don't have access to any of that. Cambodian Central Bank, together with Soramitsu, developed a system, blockchain-based banking system for the unbanked, which means that all these people automatically get a bank account created for them with the Central Bank of Cambodia. So they're not attached to a specific bank. They're not with Bangkok Bank or Ayutthaya Bank or SCB. They are account holders with the Central Bank of Cambodia. It's a blockchain-based system. And as soon as they are registered, people, companies, governments can transfer money into that account. And then those individuals can use those bank accounts like they would any other bank account. As soon as there's money in that account, they can transfer that money. They can do overseas transfers. They can do local transfers. They can, you know, apply for credit cards using this. They can apply for payment cards, like you have Rabbit Card here in Thailand. You know, they can start doing all that. They can start using these accounts to pay at 7-Eleven and other shops and supermarkets. So this is really a blockchain-based system created to create transparency and to allow those people that don't have access to banks or the banking system today to become bankable and therefore to have access to the same amenities that we're used to, that we're accustomed to. So that's one example. There's another example I used before, which is called Ripple, which is a blockchain-based system for interbank transactions. So you wouldn't, as an individual, necessarily come across it, but this is where banks are dealing with each other, like I said, in Europe and Scandinavia, where banks are actually managing transactions between banks using blockchain rather than the traditional interbanking system where you had responding and corresponding banks. So they've actually cut out all those middlemen and do transactions in cryptocurrency on your behalf when you're transferring from one bank to another bank. You know, they transfer that they convert it into a cryptocurrency, send that cryptocurrency, which is received immediately, and then convert that back into local currency. So as a recipient or sender, you wouldn't notice that this is happening. but you can, as a bank, in the background, it works for them. You have justice systems that are using blockchain solutions. So you have solutions in the US around digital evidence sharing. So evidence is collected by detectives, by police forces, by fire brigades. It depends on what type of evidence you're looking at. And they're actually posting that evidence in blockchain-based environments where it's easy to digitally share that evidence with other departments anywhere in the country and even anywhere in the world with secure verification. So it's not that public access to it. This is a private consortium system for judiciaries and police departments and fire departments. Similarly, for the police departments, they have a different blockchain solution for evidence collecting for digital forensics, where again, it's easy to share that data now across juristic borders or jurisdictional borders. And previously, it was all stored in private databases in each jurisdiction, and therefore you might commit a crime in one jurisdiction, and people or police officers in another jurisdiction wouldn't even know that had happened because they wouldn't have access to that data. Blockchain removes that barrier by making it decentralized and therefore accessible to anyone. And another system they're exploring and playing with in the US is proof of delivery. This is more around court orders. Right now it's an individual that gives you a court order, and here, they want to digitize this and add that proof of delivery of court orders or evidence or forensics, any type of evidence or any type of documentation that they can actually prove it was delivered to a person. Similarly, in logistics, you have contract management systems around using blockchain technology to make sure that documents become tamper-proof, that identity is managed, that it's all completely transparent process, where today this is really a very, very manual, labor-intensive, heavily documented process. And governments are looking at blockchain systems, and some governments have absolutely applied them, looking at voter registration and voting registration. So being able to register as a voter on blockchain, where you can, as a voter, prove that you have registered to vote, you want to vote, you have proof that you want to do it, and also prove that you have voted. So to counter, tampering with votes. Now, if you go to a voting booth, and I remember a friend of mine going to Malaysia and then coming back from Malaysia with a finger full of ink because that was proof that he had gone and voted. This can be a blockchain-based system where, again, it becomes tamper-proof. It's linked to your identity. And similarly, NATO and the US Department of Defense are now starting to use the KSI blockchain. KSI blockchain was developed by the country of Estonia, and the country of Estonia has widely deployed this to guarantee the integrity of government data enforcement. So they've actually built this in Estonia and rolled this out in Estonia, where the public can safeguard the data and how their data and how that data is being used by the government. So the public actually gets a huge amount of control in how the government is dealing with data that belongs to the public. And this is now being looked at, by NATO and US Department of Defense. So these are different industries with different applications of blockchain. And we're getting very close to the Q&A, so I'm going to round it up now. More and more, transparency, both internally and externally, is becoming a priority, is becoming a must. The public is demanding transparency. You can see that with even in different industries, with the rise of things like TripAdvisor, where people trust the voice of other people more than they trust institutions and governments. And therefore, governments and institutions need to make their data, their use of data, more transparent. Decentralization is absolutely on the rise. You can see that with social networks. You can see that with how quickly things are shared around the world, how quickly data is transferred around the world. This is becoming new normal, and especially when you have global pandemics, access to data, immediate access to data, and open distribution and transparent distribution of that data on a global scale is becoming a must. Decentralization, automation is on the rise. Data and companies need to be scalable. Solutions need to be scalable, and traditional databases just don't cut it when you're talking about scalability. Blockchain is immensely and indefinitely scalable by adding more nodes to the network, and each node already has a complete copy of the database, whereas a traditional database structure, duplicating that database is quite an endeavor for most companies, and backing up that database is quite a thing for most companies. So you'll see more and more companies shifting to scalable solutions, which like blockchain and cloud solutions. More and more companies are going through a digital transformation. So looking at our data needs to be online, it needs to be in the cloud. Our solutions are already in the cloud. How do we put our data in the cloud? And blockchain is one of the prime candidates for this. Similarly, global events are happening more and more and more. I touched on, how blockchain could have helped with the COVID-19 pandemic, and believe me, there will be another, pandemic or another crisis coming on in the next couple of years. So people, companies, governments need to start rethinking how data is managed and how data is being used. Now, obviously, it's a lot more complex than what I've been able to cover in these last 45 minutes. There's a lot more to it. For that, we have additional courses and more in-depth views on these various aspects that I touched on. So having said that, I'd like to go over to the Q&A. Shaheen, do we have any questions from the audience? And again, if you still have questions, please feel free to type them into the chat and let us know.
Okay, thank you, Ivan Spleeveen. Yes, we have some questions from our audience. Here is Akhtaruzzaman Hassan. He asked about the authenticity of the blockchain. How much it is authentic?
Okay, how authentic is the blockchain? Well, it depends on the type of blockchain that you're using. If you're using a decentralized blockchain, it's 100% authentic. It's controlled by the user itself. So, if you look at a decentralized network, you have nodes that are running that network. Every node has a copy of the blockchain, of all the data on the blockchain, and that data is constantly refreshed every time there's another transaction. A transaction gets pushed into the network by a user, that goes into the consensus algorithm. So the network has to approve that transaction is going to get added to the blockchain. And one of the reasons for approving that in case of a monetary transaction is looking at, do you actually have the funds in your account to do this transaction? Are there any other transactions pending? So if we do this transaction, will it actually be possible to do the transaction? And if the answer to both is yes, and do we know who the recipient is? Yes. And do they have an account? Yes. Then this transaction can take place, and therefore it is added to the blockchain and immediately executed. So that money is then removed from your account, and your balance of your account is immediately updated. So these are all split-second things that happen. So it is extremely transparent. You can see this as an individual. You can see this as the people that built that network, and because it is decentralized, you can always look at historical data and see whether transactions went through or not, whether someone tried to cheat the network. Again, everything is stored there. And because there is no edit function and there's no delete function, all the historical data is always present. So even if you're not talking about cryptocurrency, we developed a blockchain solution for the farming industry where they needed the reports of external auditors and laboratories for animal feed. They needed those reports to be accessible anywhere at any point in time. And they also needed that verified that these reports were the one and true reports. So we had various different entities that were approving that these reports were accurate, which is the laboratory, which is the farmer receiving it. Everyone had to sign off. And as soon as everyone signed off, that report was added into the blockchain, and therefore it became irrefutable. Yes, all the entities agreed that this report is a true report, and therefore you can trust the report. You don't need to trust, the 30 people involved in your distribution chain.
Okay, thank you. Hope Akhtaruzzaman got the reply or answer of his questions. So there is another question from Abu Huraira Bhutto. He is asking about the risk management issue of blockchain, since we are aware of cyber crimes issue.
Well, again, as I said, risk management is not in the blockchain itself. The data that is stored in blockchain, once it is stored, it's irrefutable, cannot be changed. It's impossible to change it. As I said, if you have a decentralized network with 3 million nodes and users on that network, you would have to hack into more than 50% of them simultaneously, make sure that there's no other transactions taking place at that point in time that you're doing your hack, redistribute your hacked data across the entire network, and update all the hashes for all the transactions in that network that happen after your hack. So the amount of effort you would have to put in to do that would require so much computing power that you could simply take over the network entirely. And the network takeover would be, immediately noticed by the people using the network. So it is absolutely tamper-proof. What isn't tamper-proof, obviously, is the solutions built to look at that data, right? If you build a solution, that's where cryptocurrency is at issues with cryptocurrency exchanges. which were platforms where people would go to buy and sell cryptocurrency, like you have a mutual fund trading exchange or stock market exchange. There was the same for cryptocurrencies, where people would go to that exchange. The exchanges got hacked. So the exchanges were taking a decentralized approach, and that's where the problem began, where in a cryptocurrency blockchain, all the data sits in the blockchain. What an exchange would do is they say, no, we're taking the data off the chain. We do all these transactions within our exchange, and at the end of the day, we're sending that data as one transaction back to the blockchain. So that's a mistake that they made in how they were dealing with the data. It never changed the information on the blockchain being correct, but it did change the information in the exchange being incorrect because it was no longer using that blockchain principle. So blockchain is 100% tamper-proof. It's never been hacked. And believe me, people try all the time. We have a separate session completely dedicated to the different hacks and the different attacks that happen for blockchain technologies. I can literally spend 3 hours talking just about that. So we can't cover that today, but there is distributed denial of service attacks. There's a wide variety of attacks depending on the type of blockchain you have. All of those are being catered for within the blockchain framework. It's systems that sit on top of it that might misuse it that are hackable. Now I saw 2 more questions coming up there, Shaheen, that I quickly want to address as well. Someone asking about how effective technology is in education management. It's the same principle as I said before around digital identity management. So you could do the same with education management. You could have an education blockchain, which is decentralized and therefore used by all the schools and all the universities anywhere in the world, linked to digital identity. So your identity as a student, gives the education facility access to that education blockchain. And there, the institute can store your test scores, can store your degrees, your diplomas, can store that you have actually been to that school. And therefore, that information is out on the internet, but only, again, accessible to the people that you give it access to. And you could use that information for employers and say, look, you don't need to believe that the paper copy of the diploma that I give you is my real diploma. You can simply go to this education blockchain and you can see all my degrees and diplomas because they've been posted there by the institutes themselves. And the institutes have their own digital identity. And therefore, you can verify that this is truly coming from the institute. You don't need to trust me. I'm the applicant. I might lie. But guess what? This is the institute making that statement on a public blockchain. And I don't need to carry around diplomas anymore. So you can absolutely use blockchain technology in managing education purely for certification. You can do the same for testing. You can create a test system that runs on blockchain. So once someone puts their answer in, they cannot change their answer. There's a variety of applications you can actually have in education management for blockchain. Okay, there's another question there, and I think that's all. Shaheen, do we have any other? I saw one more question on data encryption. Do you have any other questions?
No, there is just query on how much blockchain is friendly with the SME.
How friendly blockchain is with SMEs? Blockchain is impartial. Blockchain works for individuals, SMEs, multinationals, corporations. Again, it depends on the type of blockchain, right? So if you're running a decentralized blockchain, that means that Bitcoin is a great example, and that applies for SMEs as well. Bitcoin is operated by the people that own Bitcoin, which means you and me. Bitcoin runs off your computer, it runs off your laptop. It doesn't need heavy infrastructure. That's the biggest difference between a traditional database and a decentralized system, is that you don't need any of that hardware and infrastructure. So it works perfect for SMEs, and it's very low cost in terms of maintenance and management. There's one more question in the chat that I also quickly want to address. How do you read data from the blockchain? In my understanding, data stored in a hash form on the blockchain and cannot be decrypted. Yes and no. That depends on how they set up the blockchain. So if you look at Bitcoin, the data isn't stored decrypted. The data is hashed. So what they do is they take all the data and they create a hash of that data, and that becomes the identifier for that transaction. So it's purely transaction-based. But you can still go onto the Bitcoin website right now and look at transactions, and you can read those transactions. You don't have to decrypt those transactions. However, what you will see there is it will say this hash account of this hash is sending, one Bitcoin to this account, which is also represented by a hash. So it's not very readable in that you only see the hashes of the account. You don't know who the account holder is, because that is only represented by a hash. Because why? Privacy. So again, this all depends on what kind of blockchain solution you're building. If you're building something with cryptocurrency, in cryptocurrency, because it's decentralized, they wanted to keep that extremely private. So they don't show you who is transacting with whom. They only show you an account is transacting with another account. If you know who the owner of the account is, you can see all the transactions they've done on the network. But if you want to build a blockchain solution that is transparent, you don't have to encrypt the data. You hash the data. The hash of the data becomes part of the transaction, and that creates proof that that transaction cannot be changed. So yes, a lot of the cryptocurrency networks are encrypted, use encryption, but encryption isn't. It's depending on your type of application. All right, that's it for the questions we can answer for today. Again, there is more coming on that, and I'll hand it back over to Joe. Thank you very much for participating today.
Thank you so much, Mr. Ivan Spleeveen. Now I would like to invite Mr. Bhoravet Chonlachin, Director of Program EIT Extension, my direct supervisor, who will come for or inviting for closing remarks.
Thank you very much, Shaheen, and thank you very much, Ivan Spleeveen from the Abalon Labs and Blockchain Labs AI for today. Very interesting sessions that I believe that more than 30 audience that watching now from the Zoom webinar and many more from the Facebook Live already get some basic idea what is blockchains and how blockchain can be applied into the situation and into the organization, into the operationals of the businesses. As you can see, this webinar is a webinar as part of the Tech Talk series of AIT and AIT extensions. So we will have many more topics that we can offer you with a basic information on the digital transformation, just to serve you, to give a basic knowledge that the organization, especially during COVID-19, has to prepare their understandings and also the basic platform where the companies and business have to move forward. We are now also developing a short courses training programs in the series of the digital transformation that we also offering to you and sharing with you later on this week, that within this digital transformation short courses, we have at least 9 short courses that you can apply to attend the course, and this course will be full of the details and also the techniques and solution in more detail, where your company can apply into the specific sections or specific units of the company's operations. So we are going to send you the information later on this week, the course which is available for you to attend. And this course, you don't need to, you don't need to apply for every course that we have in this series. You can also select for some course that which is very important for the company, or the course that is the priority in your company right now. So it's also optional for you to select a long courses with a long weeks, or you can also select the course that can complete within 1 day or 2 days or 3 days. So it depends on your needs. It depends on your requirement. We also have we have discussed also, we would also have some kind of the organization or solution where if there is a request from your company for AIT and also the labs that we are working on to customize the course into specific sectors, specific technologies, we also will be willing to discuss with your company further in detail, so that we can run the specific program and specific consultancy to your company later on. So again, let me thanks all of you for your participation today. And actually today is just a starting day of having you familiarized with the digital transformation. So we are looking forward to have you in our next programs and also training program in the very near future. As I said, we are sharing with you the information very soon, so that you are clear what we are talking about, what are the options that you can make into the knowledge transfer. So thank you very much, and looking forward until we see you again.